Today's objective is prime factorization. Definition number 1. A factor is a number multiplied by another number to get a product. Remember, product means when you multiply two things together. 4 is a factor of 8 because 4 times 2 gives us 8. So 4 and 2 are both factors of 8. Definition number 2. A prime number has exactly two factors, 1 and itself. For example, 2, 3, 5, and 17 are prime numbers. For 5, the only two numbers we can multiply together to get 5 are 1 and itself, 1 and 5. 17, the same way. The only two numbers we can multiply together to get 17 are 1 and 17. There are no other factors for that number. Definition number 3. Composite numbers have more than two factors. So these numbers could have 3, 4, 5, 6, several factors. For example, 4 is a composite number. You can multiply 1 and 4 to get 4, or you can multiply 2 and 2 to get 4. So that is a composite number. 15 is a composite number. You can multiply 5 times 3 to get 15, or 1 times 15 to get 15. So it has more than two factors, it's composite. 1 is neither prime or composite. Remember that. 1 is neither prime or composite. It's special. Definition number 4. Prime factorization is when a composite number is written as the product of its prime factors. So prime factorization is done for composite numbers, and we break those down into a product of the prime factors. Vic 1. Use a factor tree to find the prime factorization of a number. Vic number 2. Write prime factorization in exponential form. Remember, exponential form is with exponents. Vic number 3. Multiply factors to check yourself. You can check yourself on these prime factorization problems. Let's try them. Example 1. Instructions. Find the prime factorization of 120. Use a factor tree. Well, the first thing we're going to do is we're going to decide, is 120 a prime number or a composite number? Well, there are more than two factors to 120, so we know it is a composite number. So we can do our factor tree. I'm going to show you how you can do it two ways. What are some numbers we multiply together to get 120? I don't know, 12 and 10. These are factors of 120. We're going to take those factors and break them down until we get prime numbers. 12 is composite. What are some numbers you multiply together to get 12? Well, 3 and 4 give you 12. We're going to circle 3 because it is a prime number. 4 is not prime. What can you multiply together to get 4? 2 times 2. Those are both prime, so we're going to circle them. 10. 10 is not prime, so we're going to break it down with a factor tree. What numbers can you multiply together to get 10? 2 times 5. 2 and 5 are both prime, so we're going to circle them. Now, we have all of our branches that have stopped because they are prime numbers. So we're going to list those numbers as a product. So, 2 times 2 times 2 times 3 times 5. Where did I get that? You list out all of the circled numbers in order. So 2 times 2 times 2 times 3 times 5. Let's write that in exponential form. We have 3 2's. So we're going to do 2 with an exponent of 3. 2 to the third power times 3 times 5. This is the prime factorization of 120. Let me do it a different way just to show you that it works. What are some other numbers besides 12 and 10 you can multiply together to get 120? Well, how about 2 and 60? 2's prime, so let's circle it. 60 is not prime. What can we multiply together to get 60? 2 times 30. Circle your 2. What about 30? What are some numbers we can multiply together to get 30? How about 3 times 10? 3's prime. Circle it. What are some factors of 10? 2 and 5. Again, you end up with the same thing. 2 times 2 times 2 times your 3 times your 5. Write it in exponential form. 2 to the third power times 3 times 5. That is the prime factorization of 120. Let's check ourselves. What does 2 to the third power mean? 2 times 2 times 2, which is 8. 8 times 3 is 24, and 24 times 5 should give you 120, what we started with. That's how you can check yourself. A few more examples. Example 2, the prime factorization of 750. Think about it. 750 is a composite number because you can multiply more than 1 and 750 to get it. So, it ends at a 0. So you know that means it is divisible, or 10 is a factor of that number. So 75 times 10. Can I stop there? No, because those numbers are not prime. How can I break down 75? What can I multiply together to get 75? 25 times 3. Can I stop at 3? Yes, it is prime. Can I stop at 25? No. 5 times 5 gives us 25. I circle those because they are prime. And break down 10 to 2 times 5. Circle them. I have all of my prime numbers circled. So we're going to list them out. 2 times 3 times 5 times 5 times 5. Remember, a product of the factors. Write it in exponential form. 2 times 3 times 5 to the third power. 2 times 3 is 6. 5 to the third power is 5 times 5 times 5, which is 125. And 6 times 125 does give you 750. This is the prime factorization or answer to that problem. Example 3, 26. For 26, is it composite? Yes, there are numbers I can multiply together to get 26. 2 times 13 gives me 26. 2 is prime. 13 is also prime, so we can stop. Our solution or our answer is 2 times 13. We can't write that in exponential form because there's not more than one 2 and there's not more than one 13. Last two examples. 68. What are some numbers we can multiply to get 68? 2 times 34. Stop there at 2. Circle it. What gives us 34? Well, 2 times 17. 2 is prime. Stop. Circle it. 17 is also prime because no other numbers multiply together to get 17. So our prime factorization, 2 times 2 times 17. Write it in exponential form, 2 2, so 2 to the second power times 17. Check yourself. 2 squared is 4. 4 times 17 does give us 68. Last example, 113. Think about it. Is that prime or composite? 113 is actually a prime number. So we are unable to find the prime factorization because it is not a composite number.